Okay, so we're about to start section 4.4, the equation of a line from a description. So in the previous lesson, we looked at how to make an equation of a line from a graph. Okay, and in this lesson, we're going to be looking at how to make an equation of a line just from a description. So just using words. Okay, but first, I do want to go over what we did in the previous lesson, and that was finding the rate of change and the rise, which is the rise over run, and finding the initial value or y-intercept from a graph. Because I think just going over that information will be beneficial for this lesson. Okay, so I do want to just go over that. So let's look at that now. Let's start with the easy one, which I'd say is the initial value or y-intercept. That's obviously the point that crosses the y-axis. It's our first point. It's the one that crosses the y-axis. All right, let's look at this graph and try to understand what's going on. So it's a fir tree growth. So it's the growth of a tree. We'd see that on the y-axis we have the diameter in inches, and on the x-axis we have time in years. Okay, and looking at my scale, looks like I'm going by fives on my x-axis, and it looks like I'm going by fours on my y-axis. Okay, so I'm just filling in the numbers in between. All right, that might be helpful for us. Okay, and I suggest you do that as well. If you see numbers not filled in right in the beginning, just throw in those numbers into the scale so that you see it in front of you, and I think that'll make things a little bit more clear. So what is the initial value? Just a note here that the x value is always zero for the initial value. Because it is always on the y-axis, our initial value, the x value will always be 0. It will always be 0 for every initial value or y-intercept. So the initial value or y-intercept here, if I were to write it as a coordinate, it would be 0 for x, comma, and it looks like it's right in between 8 and 12. So right in the middle of 8 and 12 is 10. Okay, so you could either write it like this, or you can write it as simply 10. Okay, so that's the initial value, and I wanted to start there just because it's a little bit easier to find than calculating the rate of change. So next, let's do the rate of change up here, and let's pick 2 points. Let's remember the steps. We're going to pick 2 points. So I'm going to pick this point here at the very top, okay, and I will just pick this point right there, okay. Now, step 2 is to draw your 90-degree angle triangle. So I will do that, okay. Now we're going to find the rise and the run. The rise and the run. So let's see how to figure out the rise and the run here. Let's start with the rise, okay. I need to figure out the distance from here to here for the rise, right? That would be my rise. This distance right in here. Okay, there's my rise. So if I go across here, what is this value right there? It looks like I'm at 30 on the very top. And what is this value right here? Looks like I'm at 18 at the very bottom. So I went from 18 to 30. So what would be my rise from 18 to 30? Well, it would be 12. Okay, so the rise equals 12. I went up 12 units on my scale. How can I figure that out instead of just asking myself, what was the rise from 18 to 30 and just knowing that it's 12? I mean, there's a calculation I can make. Okay, I can actually take my 30, subtract 18, and that's how you can actually find 12. We could do the exact same thing for the run. Okay, so the run distance, you are finding it's inside here. Okay, so we're going from 20 down here all the way up to 50 right there. So how much did I run across to the right? I went from 20 to 50. Well, a way to calculate that is just do 50 minus 20. So I end up getting 12 over 30. Okay? So now we can reduce that. Okay, so we can reduce that fraction. So I'm going to do that. I know that what number goes into both 12 and 30? 6 does. Okay, 6 goes into both. So I'm just going to divide both by 6. And I end up getting 12 divided by 6 is 2. 30 divided by 6 is 5. Okay, so I end up getting 2 over 5 as my rate of change. Okay, so that's just a recap on how to find rate of change and the initial value, or the y-intercept. Now let's get down to what this lesson is all about, and that is finding a linear equation from a description. So let's look at this example right here. Okay, a car can be rented for an initial fee of $75 plus an additional 20 cents per kilometer. Write a linear equation that represents the total cost of renting the car. Okay, so all we have to do is write an equation. And remember that the general form for an equation is y equals rate of change times x plus my initial value. So all we have to do is identify which one of these two numbers is my rate of change and plug it in there, and which one of these numbers is my initial value and plug it in there, and we're done. It's that simple. You don't have to put anything for x and y. Okay, you leave that as x and y because it could be an infinite amount of values, really. It could be a lot of different values. So you just leave them to be generally just x and y. Now I'll come back to that later because you don't have to call them x and y. We can call them different letters. And so I will come back to that in a second. Let's just write out our equation. Okay, so you can see in my work below here, I have identified that the rate of change is 0.20. So your rate, it's always going to be the one that has like the word per, or maybe it'll have a slash. So per or slash, or maybe it'll say each. Okay, where you see those words or where you see that slash is where you know for sure that you have found the rate of change. Okay, so in this case, it's right here. It's 20 cents per kilometer. That's my rate. Okay, that is my rate. So I can just write it as 0.20. I don't have to show the units there. Okay, and then of course your initial value. I mean, it actually says initial fee of $75. So of course my initial value will be 75. Okay, and what that means is that my graph is going to be starting on the y-axis here. It will be starting at 75. That's what that means. So as I write my equation, there it is. All I did was I took the 0.20 and I replaced rate of change with 0.20, and I took my initial value and I replaced it with 75, and I wrote out my equation. But one thing that I do want to discuss, like I mentioned earlier, is the fact that you don't have to use y and x as your letters. In fact, when you get a real world problem, it's probably easier to understand if you don't use y and x. Okay? Because look at what the question says. It says, write a linear equation that represents the total cost of renting the car. So instead of writing y equals, how about we do this? How about we say that since we're finding what the total cost is, instead of using y, why don't we put capital C for cost? Okay? So instead of y equals, we're putting cost equals. Okay? And put your 0.20. And instead of x, this is always the tricky one. Okay? This is the tricky one where students don't know kind of which letter to use. Your x variable here, there's a little trick in a description. It is always the second part of your rate. See how the second part of my rate says per kilometers? Per kilometers. Okay? Think of the way this equation is. It's 20 cents times the number of kilometers that you drive. Okay? So instead of x, we could do 20 cents times maybe the letter n, meaning number of kilometers. Okay? And then plus my 75. So let's look at this equation again. Total cost equals 20 cents times the number of kilometers, n, plus 75. That's how you find the total cost. You multiply 20 cents times the number of kilometers that you drive, and you add 75. Okay? A lot of the questions that we do, I'd say 90% of the questions that we do are cost questions. And so pretty much always on the left here, as long as it's dealing with finding the cost, you will get C on the left. And this letter here could change at times. In this particular case, I used n for number of kilometers, but that variable will always be in the second part of your rate, like after the slash or after it says the word per, okay? It will always be hidden in there. So it's number of kilometers, okay? So let's practice it again here with another example. All right, a t-shirt company's expenses include a startup cost of $5,000 and an additional $15 for every t-shirt they produce. So $15 for every t-shirt they produce, or $15 per t-shirt. Again, that key word being per t-shirt that they produce. Determine a linear equation for the company's total expenses, then fill in the table of values. Okay, so we can come up with our equation here. Okay, so y equals rate of change times x plus the initial value. Okay, so now we have to identify which number here is the rate of change. Okay, it is the 15. Because it has the word per, or it doesn't say the word per, but $15 for every t-shirt means $15 per t-shirt. Okay, so this ends up being our 15 right there. And our initial value, it actually says a startup cost, which is our first cost. That is our 5,000 right there. Okay, and that's what I wrote in the rest of the document. You can see here that the rate of change is 15 and the initial value is 5,000. Okay. So here's our final equation. Okay, but let's write it with different letters than y or x. Okay, so I told you, like, if we look here, it says that we're finding the total expenses, or again, we can just say the total cost. So you can put, again, a capital C on the left because we're finding the cost. It's $15 per t-shirt. So times the number of t-shirts. Okay? So you can use the letter N or the letter N for number or T for t-shirts. Okay? Plus 5,000. Right? And now it makes sense when you read it. It says the cost equals $15 times the number of t-shirts and then add 5,000 because that's our initial cost. Okay? So it makes sense to replace the y and the x in this case with a c and a t because it's more relevant to this word problem, right? Y and x is more, they're kind of more just a strictly theoretical mathematical variables, whereas c and t gives this more meaning. It gives this equation more relevance because it has to do with this question in particular. Okay? So let's move down because I do want to do one more thing. And there you go. I wrote that equation actually in your document there. Okay, so it's the same thing as here. Okay, so now there's one thing more that I want to do, and that's to fill in, take this description, okay, so the description at the top of the page there, and fill in this table. Okay? Well, I already have the equation. So I already know, now remember that your x values in the table, you come up with these, you make them up. You totally make up which x values you want to use. I would always start with 0, okay? But the rest of them you can make up. And why did I choose 1,000, 2,000, and 3,000? I chose them simply because if you're selling or producing t-shirts, you're probably selling them, a lot of them most likely in the thousands, and so I chose to go by 1,000s. If I did 0 t-shirts, 1 t-shirt, 2 t-shirts, 3 t-shirts, that probably wouldn't be the most it wouldn't make the most sense, because chances are you'd be selling or creating a lot more t-shirts than that. So I chose 1,000, 2,000, 3,000, but you decide which values of x to use. Okay? But then you then have to calculate what C, or what the cost will be. Well, we have the equation up here, right? We have the equation. We know that cost equals $15 times the number of t-shirts and then plus 5,000. So let's find cost, right? Let's fill in the rest of this table by finding the cost C. So C equals $15. Now, next is my N, which is number of t-shirts. Well, my N here is 0. Okay, let's say I sold 0 t-shirts. So it'd be 15 times 0 plus 5,000. So I'm basically just plugging the 0 in for N right there in my equation. I'm plugging in 0 for N. What do I get? 15 times 0 plus is 0 plus 5,000. Well, that's 5,000. And that makes perfect sense. My initial value is $5,000. So I should get 0, 5,000. Right? Remember that for the initial value, the x value is always 0. Next, 15 times, this time it's 1,000 t-shirts, and then add 5,000. Okay, so 15 times 1,000 is 15,000, plus 5,000, I'm up to $20,000 in costs. Let's do this again. C equals 15 times 2,000 this time, right? Because I have 2,000 t-shirts. Okay, 15 times 2,000 is 30,000, plus 5,000 is 35,000. And lastly, 15 times 3,000 is 45,000, plus 5 more, I get to $50,000 in costs. Now you may have a question and say, but sir, how many numbers for X should we use in the table, right? We used 1, 2, 3, 4 numbers. I would say use at least 4 numbers. You don't have to do more than that, but you should probably do at least 4. So I'd stick to about 4 numbers. Okay, I'd probably accept 3 as well, but 4 numbers is a good number to use. Okay, so remember, you come up with the X, or in this case, they're N numbers. You make those up. I mean, you could have used 0, 10, 20, 30, or you could have used 0, 100, 200, 300. That doesn't matter, okay? You could have used anything you wanted there. What matters is whatever you decided here, it's the number that you plug into your equation to find the cost. So find the cost for 0 t-shirts, find the cost for 1,000 t-shirts, 2,000, 3,000. Okay? And if I needed to, I can graph this because I now have 4 points. I have the point. If I needed to graph this, let's actually let's write down all of the coordinates, right? If I were to graph this, I would graph, my first point would be 0, 5,000. My second point would be 1,000, 20,000, right? They're just the coordinates x and y. My third point would be 2,000, 35,000. And my last point would be 3,000, 50,000. And that's it. Okay, so you would now be able to graph that. Of course, you would have to choose a good scale for x and y, make sure everything is labeled, right? So you'd have cost on your y-axis, you'd have number of t-shirts on your x-axis, and then choose proper scales for each one of your axes. But now you can actually go ahead and graph something like this. Okay, so that was one of the major things that I wanted to show you in this lesson as part of this lesson. Okay, and that is how to create a table of values when you now have written down an equation. Okay, so we were given a description up here. We were able to come up with our equation based on our description. Okay, right here we came up with our equation. Okay, and then from the equation now we created a table of values down here. And remember, I made up these numbers here